Finally, we are going to be looking at our third type of equation of a straight line, and that is called the general form of a line. Now, how this equation works is that all the information is on one side of the equal sign, as you can see right here, and then on the other side of the equal sign, you just have 0, so there's nothing on the other side. Now, there are specific guidelines we have to follow for the A, B, and C numbers that will appear there. Now let's begin by saying that A, B, and C cannot be fractions or decimals. Now when it comes to A has to be a whole number. And if we remember what a whole number is, it is the number 0, 1, 2, 3, and so on. So moving in the positive direction. So whole numbers do not include negative numbers. So A has to be a positive number. That is not a decimal or a fraction. Now, B and C can be positive or negative numbers. In other words, they are integers. So we can just put here positive or negative. Now, remember, it's very important that all three of those numbers are not fractions or decimals. The number that takes the place of A has to be positive, and the numbers that take place of B and C could be positive or negative. And once again, we have the x and y values here. Those two will remain as x and y once we fill in our formula, and then we can plug in any number in x and solve for the corresponding y coordinate on the graph. So now let's look at some of these questions. So for example 1, it says write each equation in general form. So they gave these to us in either slope-intercept form or slope-point form, and we need to convert it into general form. So I'll write down the step-by-step that you need to follow in order to do that. So for A, they gave us an equation in slope-intercept form, and we need to get it to general form. Now remember, general form has everything on one side of the equal sign. So our very first step here is going to be to move all terms to one side of the equal sign. So I'm just going to move both of these terms to the left side of the equal sign. So whenever you do that and whenever you move a term to the other side of the equal sign, the only thing that changes is the sign in front of it. It switches. So then this term here will become plus 2 over 3x. So I'm going to put that down. And then the plus 4 is going to become minus 4. So I'm going to put minus 4. And then the y is there as well. So I'm just going to put plus y because we didn't move that at all. So it still stays positive. And then we're going to have equals 0 because there's nothing left on the other side of the equal sign. And you know what? Let's rearrange these so that they're in the order that we have up here. So we have the term that has x first, then the term that has y, and then the number on its own. So I'm just going to put the term with x. So that's 2 over 3x. Then I'm going to switch and put this plus y next, and then minus 4 is equal to 0. So that's our step number 1. So if we're comparing what we just wrote down here to this equation up here, this is our a, so the 2 over 3 is an a. Then in front of this y, there's an invisible 1, and that would be the b value. And then this value is the c. So that's these letters up here. So our next step is, well, you'll notice we have a fraction there. So this here cannot be a fraction. So our next step is to get rid of that fraction. So we need to cancel out that denominator. So our step number 2 is going to be to get rid of that denominator of 3. And we're going to do that by multiplying both sides of the equal sign by 3. So there I quickly wrote down step number 2, and now let's actually do that. So I am going to multiply both sides of the equal sign by 3. So let me just quickly write down our equation. Then I'm going to put brackets around this entire side of the equal sign, and we are going to multiply it by 3. And I'm going to also put brackets around the other side of the equal sign, and we are going to multiply it by 3. I just put a little multiply dot there. So when we have multiplication outside of the brackets, we need to distribute it inside of the brackets. So we're going to take this 3 and multiply it to every single term inside the brackets. So if we were to rewrite this down, we would have 3 times 2 over 3x plus 3 times y, and then 3 times negative 4 would just be negative 12. So that's what we have on that side of the equal sign. Then I'm going to put the equal sign, and then 0 times 3 just stays as 0. So then in our final step, let's just clean this up a little bit. So let's look right there. We have 3 times 2 over 3x. Well, the 3 in the numerator is going to cancel out the 3 in the denominator. So all we're going to be left with there is 2x. Then we have plus 3y, and I'm not going to write that little dot in between because we don't have to. And then minus 12 is equal to 0. And that there is the final answer written in general form. So we just converted from slope-intercept form to general form. And you'll notice we have no fractions for our a, b, and c because we have ax plus by plus c is equal to 0. But this sign here could be positive or negative because remember, c could be positive or negative. So this is the values we have here, and they kind of correspond like so. So now let's try one in slope point form. So these ones are a little more tricky because we have a set of brackets that we have to deal with first. So the first thing we're going to do is get rid of those brackets. So we are going to do so by distributing this fraction into the brackets. So we're going to multiply it by both terms inside of the brackets. So the y minus 1 is going to remain the same on that side of the equal sign. Then we're going to put equals 3 over 5x, and then that plus 3 over 5 is going to be multiplying the 2. And then we can clean this up a little bit, so we'll do y minus 1 is equal to 3 over 5x plus, then we have 3 times 2, which would be 6 over 5. Because remember, when we're multiplying a fraction by a regular number, we can just imagine that they're both fractions. So there's an invisible over 1 there. And then we would multiply the numerators to get the 6 and then the denominators to get the 5. Now I'm looking at this and I'm seeing a lot of denominators. We have those 2 5s in the denominator. So to make things easier for us, in my next step, I'm just going to get rid of those denominators by multiplying both sides of the equal sign by 5, because that's going to cancel them out. Now, I just want to remind you that we're multiplying both sides of the equal sign by 5 to keep it equal. Or else, if we didn't multiply both sides of the equal sign, then our equation would no longer be equal. So here I'm putting brackets around both sides, and then I'm writing the 5 out front of them, because that means we're going to multiply every term inside those brackets by the 5. So then if we do that, we're going to have 5y minus 5 is equal to, now remember, when we multiply this 5 and this term here, the denominator is going to cancel out. So we're going to be left with, let me put that there, we're going to be left with 3x, and then again, this denominator will cancel out once we multiply the 5 to it. So we're going to be left with plus 6. So this is already looking a lot better. So now let's move all the terms onto one side of the equal sign. Now last time we moved all these terms to this side of the equal sign, which is okay, but remember, with the general form of the equation, we need whatever number is connected to x to stay positive. And if we look down here, this 3 is already positive. So if we were to move this term to the other side of the equal sign, we would then have negative 3. And we would have to have one more step in there to get rid of that negative in front of the 3. So we'd have to multiply everything by -1. So let's just avoid that, and let's move these ones to this side of the equal sign, because then that 3x will stay positive. So when we move all the terms, we're going to have nothing left on that left side of the equal sign, so 0, and then it's going to be equal to 3x plus 6, then minus 5y, because remember, this is going to change the sign, and then plus 5, because this sign is also going to change. And now let's just combine like terms and put them in the order of x, y, and then the number. So we're going to have 0 is equal to 3x, and then 6 plus 5 is equal to plus 11, and then minus 5y. And our final step is to write the x term first, then the y term, and then the number. So we're just going to switch those two around. So we're going to have 0 is equal to 3x minus 5y plus 11. And that there is our final answer. Now for the next question, they want us to determine the x and y intercepts of the line, whose equation is 3x plus 2y minus 18 is equal to 0. So remember, the x and y intercepts are where the line touches the x-axis and the y-axis. So it's that coordinate point. So they want us to figure that out. So let's start with the x-intercept. Now the x-intercept occurs when the y value is 0, or when y is equal to 0. Because remember, whatever coordinate point we have on the x-intercept, let's say this one, the coordinate here would be 7, 0. So the y value is always 0 when that x-intercept is occurring. Now, because of that, we can just plug 0 in for the y value in our equation and then solve for x. So let's write down our equation. So we have 3x plus 2y minus 18 is equal to 0. And what we're going to do is we're going to let y equal 0. So I'm going to rewrite this whole equation, but in the place of the y, we're going to plug in our 0. And now we're going to just solve for x. So let's start off by multiplying. Well, 2 times 0 is just 0, and then minus 18 is equal to 0. Now let's combine like terms. We have 3x, and then 0 minus 18 is just minus 18. And that's all equal to 0. And now we're just going to solve for x. So we're going to add 18 to both sides of the equal sign, because that's going to cancel this one out, and we're going to be left with all the x's on one side. So 3x is equal to 18, and then we got to get rid of that 3 next to the x. So I'm going to divide both sides by 3. So our final answer here is x is equal to 6, and therefore that is the x-intercept. So if I were to put this on the graph, because step B, it says to graph the line, well, we know the x-intercept is right here. So I'm going to put that there, and that coordinate point is 6, 0. Now let's continue and find the y-intercept. So we're kind of squishy for room, but that's okay. So we'll just do this, and we are going to solve for the y-intercept. Now for the y-intercept, it's the opposite. If you think of any point that's on the y-axis, for instance right here, the coordinate point there would be 0, 10. So now the x value is equal to 0. So it's kind of opposite, right? Because when you're solving for the x-intercept, y is equal to 0. But when you're solving for the y-intercept, x is equal to 0. So I'm going to put here occurs when x is equal to 0. So we're going to do the exact same thing we did last time. We're going to have our equation, 3x plus 2y minus 18 is equal to 0. And we're going to let x equal 0. So we're going to have 3 times 0 plus 2y minus 18 is equal to 0, and we're just going to solve for y. So 3 times 0 is just 0, so let's just not even write that. We're going to be left with 2y minus 18 is equal to 0, and then we're going to add 18 to both sides of the equal sign again. So 2y is going to be equal to 18, and then we will divide by 2. So y is equal to 9. So this here is the y-intercept. So that's when y is 9. So I'm going to put that right here at 9, and the coordinate point there will be 0, 9. And now let's graph the line. Well, let's connect these 2 points. So if you have a ruler, please use it. I don't have one on this software, so I'm going to try my best to graph this right through. And remember, this line's going to go on forever and ever and ever. So make sure you have those arrowheads on the ends of the line, and it doesn't stop at those 2 points. And try to get into the habit of labeling the equation on the graph. So I'm just going to put here 3x plus 2y minus 18 is equal to 0. So we labeled our line, and we have 2 coordinate points there labeled as well. So in step C, it says verify that the graph is correct. So in order for us to do that, let's choose any point, an exact point on our line, and then plug the coordinates into our equation. So if we look at our line, I notice that we have a point going through this right here. So this is why it's important to use a ruler, because if your line is a little bit crooked, your points might not line up exactly. So this point is at 2, 6. So for step C, I'm just going to write down that we're going to choose any point on our line. All right, so we chose the point 2, 6 that is on our line, and we are going to plug it into the equation. Now, there's a specific way to do this, and if you do this incorrectly in Precal, it is something you will lose marks for. So I have the equation of the line, 3x plus 2y minus 18 is equal to 0. Now, whenever we verify that an equation is correct, we use this left-hand side, right-hand side method. So left-hand side, I'm going to put LHS, that's left-hand side, and then right-hand side, I'm going to put over here. And then we're going to make a little T-chart. So I'm just going to go like this and like this. Now on the left-hand side, we are going to put the left-hand side of the equation or of the equal sign in there. So I'm going to put 3x plus 2y minus 18. And now on the right-hand side, we're going to put just the 0 because that's on the right side of the equal sign. And now we are going to plug in that coordinate and see if we can get the left-hand side to equal the right-hand side. So our coordinate is 2, 6, so x is 2 and 6 is y. So in the x spot, I'm going to put 2, and in the y spot, I'm going to put 6. And let's just solve this using BEDMAS. So 3 times 2 is 6, 2 times 6 is 12, and then minus 18. 6 plus 12 is 18, and then minus 18, and eventually we get to 0. So we'll notice at this step that the left-hand side is equal to the right-hand side. So I'm going to put a nice little check mark, and I'm going to put left-hand side is equal to right-hand side. Therefore, and I'm going to use my little triangle, the graph is correct. Now, the reason we use this T-chart is when we're verifying that an equation is correct, we don't know that our two sides of the equal sign are going to be equal. So if we were to just take the equation at this state, so like this, and write it with the equal sign and then plug in the x and y value, as we're going along this process here, it would say equals 0 the entire time. But we don't necessarily know that it will equal 0 at the end, like that it'll be 0 equals 0 at the end. So make sure that you use this left-hand side, right-hand side T-chart whenever you're verifying that an equation is correct or that your graph is correct. Whenever you're plugging in points into the equation to see if both sides will equal each other, you have to use this little T-chart. In our third example, we are going to determine the slope of a line with this equation. 3x minus 2y minus 16 is equal to 0. Well, unfortunately, the general form of an equation does not tell us the slope. However, slope-intercept form and slope-point form both tell us the slope of the line. Remember that m value, or wherever the m is, that is the slope. So what we're going to do is we're going to rewrite this equation in slope-intercept form. You could use slope-point form, but it would be very, very tricky to go from this equation to slope-point form because there's brackets there. So what we're going to do is we're going to rewrite this in slope-intercept form. And now remember, slope-intercept form is y is equal to mx plus b. So our goal is to get the y all by itself on one side of the equal sign. So the equation we have here is 3x minus 2y minus 16 is equal to 0. So let's just start off by isolating y. So isolate y. So we're going to just keep the y all by itself on this side of the equation. So I'm going to move the other two terms to the other side of the equation. So then we're going to have minus 2y is equal to minus 3x plus 16 if we were to bring those terms onto that side of the equal sign. Now we still have to work to get y all by itself, so we need to get rid of this minus 2 out front of it. So we are going to divide everything by minus 2. Now remember, we have to divide every single term by it so that we can get that y all by itself. So then on this side of the equal sign, we're going to be left with y, and then is equal to minus 3 over minus 2x, and then 16 divided by negative 2. What would that give us? Well, that would give us minus 8. And we can simplify this a little further because we have two negative signs, one in the numerator, one in the denominator, and we know that those cancel out. So this is really just 3 over 2x minus 8. And now at this point, we are in slope-intercept form. Y is equal to mx plus b. So this here is the b, and this here is the m. So therefore, the slope is 3 over 2, and that would be the rise and run.